We're always surrounded by light, right?
Hmm.
But I don't know about you. I don't often stop to think about what's actually happening when light hits a surface.
It really is amazing.
Like, it's more than just seeing, there's some really fascinating physics going on there.
Oh, for sure.
And today we're going to deep dive into some of that physics. We've got a really interesting set of notes here titled Reflection and Refraction.
Catchy title.
It is. And fun fact, the title's also written in Japanese.
Oh, cool.
It says, let me see if I can get this right, Ainjine.
Wow. So are these notes from like a physics student in Japan or something?
I mean, that would be awesome.
Oh,
It's not clear, but I like where your head's at.
me too.
So, the notes start off with this concept of reflection.
Hmm.
And maybe the easiest way to think about this is, well, imagine like shining a flashlight on a mirror.
Okay, yeah, I can picture that.
So what's going on there?
Well, when that light from your flashlight hits that mirror, that smooth surface, some of it obviously passes through,
Right.
but some of it bounces back. And that's what we call reflection.
Okay. Yeah, that makes sense.
Yeah.
But then the notes get a little bit more in depth. They start talking about this thing called the angle of incidence and the angle of reflection. And I feel like we're about to get a little bit geometrical here.
A little bit, but it's simpler than it sounds, really.
Okay, good.
So think about it this way. The angle that your flashlight beam hits that mirror, that's your angle of incidence.
Okay.
And then the angle at which that light bounces back, that's your angle of reflection.
Gotcha.
And here's the crazy part. Those two angles are always equal.
Always. Like no matter what. That seems oddly specific for something as, flighty as light.
Right, right. But that's the beauty of physics. I mean, there's this underlying order to everything in the universe, even in something as, seemingly simple as light bouncing off a surface.
Yeah, okay, I like that.
And the way we describe that order, the way we can actually, capture those angles mathematically is through something called vectors.
I have vectors.
Exactly.
Okay, so vectors are really powerful when it comes to understanding direction.
They are. So a vector, it's not just about how much of something there is, it's about which way it's going.
Okay.
So you can kind of think of it like an arrow, right? It has length, which shows the magnitude, how much.
Right.
And it's pointing in a very specific direction.
Okay. So how do vectors actually help us understand,
Yeah.
this reflection that we're talking about?
So in these notes here, you'll see symbols like IVEC, IRVEC, and N.
Lots of arrows.
Yeah, lots of arrows, exactly. Those represent the direction of the incoming light.
Okay.
Reflected light, and then the surface itself, right? Like the mirror in this case.
Gotcha.
So think about them as those arrows pointing the way those things are going.
Okay, I think I'm starting to visualize this. But how does that then relate back to, those angles always being equal?
Connects all of these vectors. And it's through that equation that we can mathematically prove that, why the angle of incidence and the angle of reflection are always the same.
Wow.
It's like a mathematical mirror kind of reflecting the precision of the physical phenomenon itself.
That's awesome. So this isn't just a visual thing. There's this whole mathematical underpinning to it.
Absolutely. And here's where it gets really, really interesting.
Okay.
This principle of reflection, it's not just some kind of abstract concept.
Right.
This is the backbone of so many technologies that we use every single day.
Oh, really? Like what?
Well, I mean, the most obvious example is just mirrors, right?
Sure, yeah.
But think about fiber optic cables. They transmit information over these huge distances.
Right.
And they use light that's constantly being reflected inside that cable.
Well, that's cool.
Right. Or periscopes, right. They allow you to see around corners. Totally. Even solar energy technology, right?
Yeah.
That relies on reflection to concentrate sunlight.
Wow. So I never even realized that, reflection was so fundamental to so much of our modern world.
Well, it's everywhere. And understanding, those basic laws of those angles, the vectors, it gives you this whole new appreciation for how those technologies actually work.
Totally. So we've learned that reflection is more than meets the eye.
I see what you did there.
Oh, come on. No, but seriously, it's a precise phenomenon with real-world impact, and it's all governed by these super elegant mathematical principles. But hold on a second. There's another side to this story, right?
Oh, yeah, for sure. We got to talk about refraction.
Refraction. Okay, so for those of us who maybe haven't thought about this since high school physics, What is refraction?
Okay, so refraction, it's what happens when light passes from one material to another, like from air into water.
Yep.
And instead of bouncing back, like in reflection, it bends.
It bends.
It bends. Yeah, think
Yeah.
about it. Like when you put a straw in a glass of water and it looks like it's broken, right?
Yeah.
That's refraction.
Oh, that's a great example. I'm
Yeah.
already, like, so intrigued to learn more about how that works.
Yeah, it's really cool stuff.
I guess we'll have to save that deep dive for another episode, though, right?
Yeah, definitely. There's a lot to unpack there.
But before we go, I want to leave you with one last thought, dear listener. So if light always reflects at the same angle, then how is it that we can see objects from different angles? It all comes down to perspective, right?
Mm.
And how our own eyes are gathering that reflected light. It's something to think about next time you're looking around, just observing the world.
I like it. Food for thought.
Exactly.
Until next time.
See you then.